So is it clear now what's meant by the gate function? Okay. So as you wish, you can define the gate function. There is no any proper rule and mathematical definition for gate function. Based on actually the function given here as a graphical representation, we can define the mathematical equation for the gate function. So here I have defined my gate function as like this. So I have defined, according to this particular graphical representation of gate function, this is my mathematical equation. That is f of t is equals to 1 during a period of minus a to a. That is minus a to a is 1. Then 0 otherwise. 0 otherwise in the sense there is no chance to have any, again a constant amplitude before minus a and after plus a. That is an actually gate function here I have defined. As you wish, you can have your gate function. Suppose if you verify the gate function in the Google, you will get the number of different functions and number of different mathematical equations corresponding to the defined gate function of a graphical representation. Okay. Then this is the same problem I have given in the in the previous slides also I have shown you. At the time I told you just I can explain this particular concept in the next class like that. Let us observe. This is also sawtooth waveform, but in this sawtooth waveform just I have given steps also how to find out for your clarification point of view. Find the Laplace transform of the given waveform as shown in figure. The same problem I have given for 10 marks in the what's it called descriptive question bank, I think. Okay, this is also sawtooth waveform. Whether it is repeating from minus t to infinity or not, that's a different issue. But you can consider a 0 to t period. If it is repeating the same for further on x-axis, on positive axis as well as on negative axis, we'll consider the waveform is sawtooth waveform. But based on this sawtooth waveform, how to evaluate mathematically, I'll show you here. Okay, let us observe. At the origin, the coordinates of this x and y axis are 0, 0. Okay, at this particular point of peak, this from 0 to this peak, what is coordinate of at this point? What's the coordinate of x, y? What is x and what is y here? Any one of you please tell me. Water please. Hello. Hello guys, I'm asking you what's the coordinate at this particular point of xy coordinates? Hello. Hello, are you following? If you're not giving proper response, I'm getting doubt myself. Whether these fellows are just listening or sleeping by switch on their mobile or doing some other thing like that, I'm getting doubt myself. Please give me response, guys. Okay, what is the, in what way can denote this coordinate of x, y here at this point, at this peak of this sawtooth waveform? At the origin, it's 0, 0. That you can consider it as x1, y1 is equals to 0, 0. If you consider this point is x2, y2, then the straight line equation and we identify the slope of that. So suppose if it is x2, y2 means what is x2 is equals to here? Please guys, give me response. What is x2 is equals to? Hello. Hello guys, what is x2 is equals to? This is x1, y1, 0, 0 at the origin. At this particular point, I am asking you in what way you can define the coordinate at this particular point of peak of sawtooth waveform. Hello. Charan, at least you have to speak out.
Ma'am, sorry ma'am, I just ran out to drink some water.
Okay, now tell me at this peak, what's the coordinate here at this peak of the sawtooth waveform? Here 0, 0 at the origin. At this peak, what's an actually?
A comma B.
A comma P.
P comma B, ma'am.
P comma B. Yeah. So that is T on x-axis and V on y-axis. So the coordinate at this peak is T comma V and here 0, 0. Now we have this particular slope and What is on x-axis? It is on x-axis is time t. On y-axis, we are denoting here it as x of t. Whatever it is, but according to the problem, we can proceed. How to proceed to get the Laplace transform of the given sawtooth waveform? Let us see. Now, is it visible, the slide? I think so. Now, first evaluate the straight line equation by identifying the coordinates. Start with the origin 0, 0 as x1, y1. Then here the two coordinates are x1, y1, x2, y2, 0, 0, t, comma, v0. V0 just I mentioned as a peak of the voltage, but if you want, you can mention v as a v also, no problem. Whatever given in the problem, just you should follow that. Then this is actually the equation y minus y1 is equals to, this is slope y2 minus y1 by x2 minus x1 into x minus x1. Okay, what y minus y1, y minus y, I mean substituting these coordinates here in this equation, then you have the equation like, let us see. What is actually y here? Y is equals to, y1 is equals to 0, is it? Because x1, y1s are 0, 0. So x1, y1 is equals to 0, x1 is equals to 0. But what is y is equals to? That is on x-axis we have, this is on y-axis we have x of t. So here x of t I have given it as v1 of t. That is for single waveform we are considering. That's the reason I mentioned here it's just v1 of t. Okay, or v of t as you wish. But just to understand the concept here, v of t. Then the peak of, that means y2 minus y1. y1 is 0 again. What is y2? v0 of t. I have given here it's a v0. But in time domain representation I'm representing here in terms of as a function of t. So v0 of t divided by x2 minus x1. x1 is 0, x2 is t. So t here we have in the denominator capital T into x minus x1. X minus x1 is 0. X is actually on x-axis you have time. So that's why small t here we have given. This capital T is the time period and small t is the time axis on x. That's why here we have given t. Is it clear how we have extracted this particular equation from the given function of periodic? Is it clear, guys? Say yes or no, ma, please.
Yes, ma'am.
1 minute. Okay, go for the next slide. Yeah, apply the gate function, then we'll get actually here. Find the Laplace transform of a given waveform as shown in the figure. Here gate function just if you have considered the gate function, I mean that is actually given in the problem, I think so. Okay, that gate function if you have considered it as GOT, that is a gate function of time period t of time, like a GOT of t is equals to 1 if the gate function exists from 0 to a, that is actually the time period of, I mean maximum amplitude of 1, that we are representing like this. This is also a gate function. For example, I have given already the gate different function in the previous slide, and this is a gate function 0 to a, it's having 1 amplitude, then leftover time, I mean otherwise it's a 0. So that is the way of defining the mathematical expression for the given gate function. Okay, if it is the gate function, then how to explain and how to apply this for the given waveform and how to evaluate the Laplace transform of the given waveform, just observe here now. See, v1 of t is equal, that means let us observe what is here, v1 of t is equals to v0 of t by t into t given. Okay, now in place of this, what is v of t, this is v1 of t is equals to v of t into gate function. V of t into gate function. Now, according to the gate function, I am defining what is an actually this this is v of t is nothing but which you have evaluated here. This is v of t is nothing but this one. This is v of t, but is consider this as a v of t. That is a v0 of t by t into t. Here I have given v of t is equals to v0 by t into t. Okay, this one is v of t. Now, what is the gate function here? Gate function, according to this gate function, we have to calculate this particular Laplace transform. Gate function, how you are going to write means, just I'll show you. This is a gate function. According to this gate function, you know already u of t, that is step function, you know. What's the step function? Just it's a 0 before 0. I mean, at t is equals to 0, it starts from 0 to the value of 1 if it is unit step function, or otherwise it's having some amplitude. So then we will call it as step function. So from 0 to 1 it will raise and it will continue like this. Okay, that is unit step function. Already you have come across it. Now what is happening here? After raising from 0 to maximum value of 1 here at t is equals to 0, but again after traveling a particular distance of a, then again it is minimizing and make it as 0 here. That means let us observe this particular equation what I have given. U of t, you know the function. Then just shifted that u of t function by t units. Okay, by t units, like u of t minus t. U of t minus t, if you have shifted and subtracted this particular function from u of t, then you will get this gate function. Guys, if you are following, please tell me, or if you are not following also, just tell me. Are you following or not? So it's a better to have actually the blackboard for this particular explanation. See, if you have the unit step function like this, okay, let us imagine this is actually the y-axis and x-axis. And here unit step function like this up to this point 0, then it is starting like this and it's a continuing like up to t is equals to infinity. Then u of t minus t, that is if t units gets shifted and it will start from here, then it is having like this. And this second function, if you have subtracted from the first function, the leftover function is this one only. Guys, is it clear? Hello, guys, are you following?
Yes, ma'am.
Then we can have that mathematical expression here to apply. That is u of t minus u of t minus t. That is t units gets shifted. That's the meaning. T units gets shifted. Suppose if you want to write in place of t as a, that's also okay. Okay, but here I have given the time period of t. That's it. That time period of t only I have given. This particular time period of the given waveform. Okay, now let us observe. So u of t minus u of t minus t. So if you have defined like this the given waveform of v1 of t for a single period, v0 by t into u of t minus t, capital T. Then just to observe, these are simple mathematical calculations only. Let us see. This t is get multiplied with u of t. So t u of t minus t, this t into u of t minus t. Okay, then v0 by t into t of u of t minus this I am separating now. But here for a simple manipulations I am doing, that is minus t and plus t added to this equation, like t into, here you have t, no? So t minus t plus t, that t minus t plus t added here, but there is no any change in the original equation, into u of t minus t only. Small t and capital T, but both I am pronouncing like TT only, don't get confused. If you are observing these equations, then only you have a better clarity regarding. Okay, t minus t plus t given here. Then again separating, sorry, v0 by t into t of u of t minus t minus capital T into, I am separating this term by dividing this into two parts, like t minus t into u of t minus t minus this plus and this minus becomes minus. So minus into t capital T into u of t minus t. Is it clear this step to all of you?
Yes, ma'am.
Yeah. Now v0 of t, v0 by t into, just observe this term to here. Just I am applying this v0 of t, separating for all the terms here. v0 of t into t u of t minus v0 by t into t minus t into u of t minus t minus v0 by t into capital T into u of small t minus capital T. Just separating this v0 by t into total three terms. Okay, please you have to enter into your notebooks. Until to put it on paper, it's not so easy to understand such a problems. But whatever I'm giving here example problems, it's not the meaning of like the same type of problems you are going to have in the final exams. There may be chance to have, because we have prepared already the question bank. So you can expect questions from this question bank only in our mid exams. But We may not expect the same type of questions in the final exam. So whatever may be the type of question, I'm giving how to actually derive and how to extract the equations and how to get the solution. Is it clear, guys? You're not inter students just to have some questions like 10 questions I have given, 10 answers I have given, just to go through that question and answers, and I'll conduct the exam only on 10 questions. Then you should be ready for writing an exam and getting cent marks of 100 to 100 out of 100. That is not my interest of getting 100 out of 100. Guys, are you following? Based on your interest, if you have gone through the different problems, if you are capable to get the solution for the different such type of problems, that itself indicates you have become actually the jumps in a network analysis. Or otherwise, it's a waste to learn these subjects of EDC as well as network analysis. I told you already, these two subjects are the basic subjects for the electronic students. Guys, is it clear, Nana? Is it clear?
Yes, ma'am.
Okay, go for the next. See, after getting this particular equation in the time domain, then you have to apply the Laplace transform. So taking the Laplace transform, now just V1 of S is equals to, that is here V1 of T is there. This is V1 of T equation. All of you have entered this equation into your notebooks. I hope those who are actually interested, I don't want to specify that interest. Those who have interest on their life, not on the subject, please put it on paper. Please, guys, I believe each and every one, because God is omnipotential. So even though you may think of it's not possible to monitor by anyone, I can do as according to my wish, but it's not possible for your life. Okay, if you're doing by your own, and if you're not concerning, or if you're not observing, and if you're not doing whatever the teacher says in the class, it's finally the loser, you only, not the teacher. Okay. Okay, just see. Now, so V1 of T becomes V1 of S. So V1 of S is equals to, and this is first term, let us see, V0 by T. As usual, this is a constant, V0 by T. So we'll get that V0 by T as usual. Then T into U of T is there. Okay, in this T into U of T, so you know what is actually T? So that is U of T we are representing as a side of that step function, but T is the main function for evaluating of Laplace transform. For T, what's the Laplace transform? Sorry, yeah, for small t, what's the Laplace transform? It's a ramp function. For ramp function, what's the Laplace transform? Hello guys, I'm asking you only, what's the Laplace transform? Hello? I've shown you that information also in the last class, and I have provided that information in the third unit notes which I have provided to you already. Is it? Guys, are you following? Third unit notes all of you have. If you open that notes, it will be visible. If t is actually the time domain, what's the Laplace transform of that? What's that Laplace transform? Guys, please, you have to open up, Nana. Third unit. Laplace transform, I have given tabular column also, and I have explained that particular tabular column. Evaluating of Laplace transform for the different functions of excitations, and given one tabular column also later on, which shows the transformation of time domain to the S domain at different functions. Hello? Hello guys? Any one of you, what is the T U of T equivalent to Laplace transform?
1 by S square.
Yes, 1 by S square. Because I have shown you that in the third unit. If you want, I'll show you once again. The third unit notes, yeah, just see, is it visible? I think so. The tabular column which I have given in the third unit, that is a ramp of t u of t is equals to S domain is 1 by S square. So the same thing here you can show, that is 1 minute of 5. That is 1 by S square in place of t into u of t is 1 by S square. Then second term. So minus V naught by t, as usual write minus V naught by t. Then t minus capital T into u of t minus t. Then you can consider this t minus t only. Okay, t minus t means in what way can I? For t we have 1 by S square. But minus t is there. So e power minus ts. Minus ts. Just to write this one. V naught by t into 1 by S square e power minus ts. Then third term is actually again minus V naught by t is a common. Then capital T into u of t minus t. This capital T is here you can consider as a constant. So t as usual you have to write. But in this u of 1 minute. This one is u of t minus t. That is u of t minus t means here for u of t what is an actually the Laplace transform? For u of t Laplace transform is 1 by s. But u of t minus t is there. That's why e power minus again ts. E power minus ts. Is it clear? Hello guys, is it clear how to extract the Laplace transform after extracting the time domain equation from the given periodic function? Guys, is it clear, Nana? Is it clear this equation? Please be practice. Then it's very easy to remember and extracting the Laplace transformation equation from the given time domain equation. Okay, is it clear this? Then only you'll go for the next. Is it clear? Hello? Is it clear, ma? Hello guys, is it clear? Is it visible? Is it visible the slide? Is it visible, ma?
Yes, ma'am.
Yeah. After this step, just see V naught by T I have taken again here common. If you want, you can take the common, or otherwise you can consider this as a common in the last step also. But in the last step also, if you are maintaining V naught of T as a common, no problem at all. So V naught of T as a common, then 1 by S square minus V naught of T here we have, but here TT gets cancelled in this last term. So V naught of T means here we have 1 by S square e power minus ST or TS. So this second term here we have. Then leftover term is V naught by S into e power minus ST. This is the third term. And just further simplification, if you observe here, V naught by T into 1 minus e power minus ST by S square in the denominator minus V naught by S into e power minus ST. This is actually S domain response of one periodic wave, that is one period of the wave which is given in the problem. Then you know already for obtaining of a periodic function, total periodic function, the Laplace transformation, that is V of S is equals to V1 of S into 1 by 1 minus e power minus Ts. Ts or St both are same, Nana. Okay, V1 of S into 1 by 1 minus e power minus Ts. V1 of S we have extracted here. So then V of S is equals to, just substitute in place of V1 of S this equation, and 1 by 1 minus e power minus St. Just multiply with this. Then this 1 minus e power minus St, 1 minus e power minus St gets cancelled in the first term. Then the leftover terms are V naught by Ts square, that is V naught by Ts square as a first term. And then here we have e power minus St in the numerator, 1 minus e power minus St in the denominator. We are leaving as usual V naught by S e power minus St by 1 minus e power minus T in the denominator. This is actually the response of a given periodic function in the Laplace transformation. Is it clear, guys? Hello, is it clear? Here we didn't given properly in the first problem. After simplification, this time period is different here. This time period is given pi. Okay. Then finally, equation is this one. The same equation here also we have, but different notations we are following. According to the given problem, you should be in a position to extract the final equation of, final response of the given periodic function. Is it clear? This is
Yes,
one
ma'am.
of one of the problems in the descriptive question bank. I told you already I'm not interested to provide the answers for the question bank, but I didn't get the reply from section A or section B regarding that 60 questions what's called answer question bank. For the question bank 60 questions for the 3 units, I didn't get the answers from section, either from section A or from section B. Yes, what's the problem? Lack of unity. Is it, ma? Lack of communication. Lack of, what you can say, understanding between the sections or between the members, because you people are joined in the pandemic and there is no question of that much of physical interaction with one another, with each other. Because of that problem also I'm expecting, I'm not getting that information from the either section of A or section B. Is it the correct reason, or is there any some other reason for not sending the information? What's your problem, guys? Amma Vinayasri? Vinayasri,
Yes, ma'am.
have completed the task which I have given before Sunday. That is on Saturday, last hour I have given the task, I think. Have finished of it? No, Anna? Say so, no? Ma Vinayasri,
No,
tell
ma'am.
me, Nana. Why?
Kada, ma'am.
Not having better cooperation among the classmates?
No, ma'am. That exams ఉన్నాయి కదా, ma'am. So that.
Okay, at least I'll give 3 days time. Is it possible to finish off it by section A and section B?
Yes, ma'am.
One question, Nana, one question. Honestly, you can try. I'm giving better scope to the students. If you followed exactly whatever the, guidelines given by the teacher, then I'm expecting out of 60 members, 20 members from each section, there is a possibility to have send marks in the subject. The reason I'll tell you, because if you have practiced the number of problems in this subject, you'll get that much of confidence to do the problems in the final exams. Then as an engineering student, you should have that much of command on mathematics. Soon after completion of the exam, you should be in a position to define your marks. If you haven't that capability of defining of your marks after completion of your exam, you are waste to join into this engineering. Because who can judge a student? Who can judge means we only. There is no one in the world to decide your knowledge and to decide your caliber and to decide your marks. You only can decide by yourself. That is then actually a magic of your desire and your confidence. Is it clear, guys? That's the reason I'm telling you, if you try just one question, whether it may be 2 marks, 3 marks, 5 marks or 10 marks, marks are not the important here, but how much interest you pay to collect the information of that particular answer, of that particular question. And that too, for each question, 2 members are there by involving A and B sections. Is it? It's not at all a difficult task. It's very easy task. But if you don't know the numbers, better to circulate the information in the group itself, A separately and B separately. And if you want any clarification from the concerned member in the section B, or from section B to the section A, then better to pass on the information to the CR. He will convey the information, then he'll get the correct information and correct solution for the problems. Is it clear, guys? Say yes or no. Dinesh, is it possible, Nana? Mukesh? Okay. Let us see the next problem. Let us note down this problem first, all of you. We'll work out this problem here. The voltage V of S for the network given by is V of S is equals to, this is a given transfer function like 3S by S plus 2 into S square plus 2S plus 2. This is function itself given in the Laplace transform. V of S is equals to, please all of you enter on your notebooks, 3S divided by S plus 2 into S square plus 2S plus 2. Plot the pole 0 diagram and hence find V of t. Pole 0 diagram and hence find V of t. That means here pole 0 concept is there in this particular unit as the last topic of Laplace transformations. So how to identify the pole zeros and how to extract the pole, V of t through this pole 0 concept. That is a very, very interesting problem we can observe in today's class. Guys, is it clear to all of you, the question? Say yes or no.
Yes, ma'am.
Okay, please all of you note down this problem. Then go for this. See, to find a number of poles and zeros, what to do means, I'll just explain this particular concept. A pole 0 concept with the different examples I'll explain later, but this is a problem directly I'm going here. In the numerator, this is numerator, this one is denominator. So the given transfer function of any of the networks consists of, on numerator, the number of zeros, on denominator, number of poles. So what are these zeros and poles in the sense? For a given network, based on the number of zeros and poles in its transfer function, we can define the stability of that particular network. Okay, that stability criteria based on the number of zeros and poles present over the transfer function of the given network, and then plotting of these poles, poles in the denominator, zeros in the numerator, on pole 0 diagram on S, that is S domain diagram also we can say. Pole 0 diagram. Based on pole 0 diagram, we can identify whether the system is having stability or not. Whether the system is having stability or not. Okay, I'll tell you one more thing. Like suppose, let us imagine you are the first batch of autonomous St. Peter's Engineering College 2020 batch. Okay, so the same information which you are actually carrying regarding the impression on teachers and covering the subjects and taking care of the students, we are expecting 2021 batch of students who may be a second batch of St. Peter's Engineering College under autonomous status. Is it? Yes or no? Say, based on that means stability in the sense, if you feel or if we train you in proper way, and if you have such a good opinion on teachers as well as an institute and the things which are moving in the institute, definitely you can convey or you can appears to be as an ambassadors for this particular St. Peter's Engineering College, and you can pass on the positive vibrations to the upcoming 2021 batch of students. Then definitely the same interesting students only can join and intelligent students only can join into the College of St. Peter's. Again, if you are conveying the same type of positive feedback, then we are expecting the better and best rankers in the upcoming years. Then the stability in the sense, suppose if you are expecting the pass percentage of from your batch, let us imagine 80% is the pass percentage of overall class, 80%. Okay, if the next batch is the best batch as compared to you, let us imagine, okay, best batch. So they got overall pass percentage of 2021 first year admitted batch, a minimum of 90% pass percentage if they maintained in the future. Then in what way can justify the batches of the students who got admitted into the St. Peter's Engineering College, and the college also have such a name, and we can have the good reputation of college and maintaining the good post percentages of students, and the stability of the college is good enough. The stability of the college means if you are maintaining same rankers and if you are maintaining past percentage of individual classes also more than 80%, then the system which exists in the St. Peter's is, we can say, it's a good enough and maintaining stability on maintaining results and inculcate knowledge on students also. Yes or no? Say yes or no, please. Guys, are you following? The same thing for a system in the networks. I mean, for a network also have some stability criteria. That stability criteria we are going to define through this particular transfer function. The transfer function can consist of on numerator zeros and on denominator some poles. Okay, now how to extract that information regarding these zeros and poles and its roots, and then you can plot the pole zero plot on S domain. Let us see. This particular transfer function consists of number of zeros, in the sense this one is actually the constant, okay, a scaling factor for the given 0 on numerator. So here yes only there, that means there is no any 0 here. Suppose s plus 1 is there, let us imagine s plus 1 is there, that is s plus 1 is equals to 0 means s is equals to minus 1, and at s is equals to minus 1 you have 1 0 to represent on pole 0 plot ani. Ikkada s plus 2 is there in the denominator, ante s plus 2 is equals to 0 means we have a pole at s minus 2 ani. At s is equals to minus 2 we have one pole. That means roots we have to identify, that is if you consider this is the root, s is equals to minus 2 is the root, and here s square plus 2s plus 2 is there. What is this? It's a quadratic equation, s square plus 2s plus 2. Definitely have imaginary roots in this. It's a quadratic ante a x square plus bx plus c. So a is equals to 1, b is equals to 2, c is equals to 2. With this, just you can identify what are the roots of s in this particular within bracket of quadratic equation. Like s1, s2 is equals to minus b plus or minus root b square minus 4ac by 2a. With this, we can find out the roots of this. Then definitely have some imaginary roots. Whatever the roots you can evaluate on the denominator, that indicates the locations of the poles. Guys, are you following? The roots which we are going to evaluate on the denominator, those are locations of poles. The roots which we are going to evaluate on numerator, those are locations of poles on S domain. Like let us observe. This is called actually S domain or root locus plot. On x-axis we have x-axis will consider it as a real axis, y-axis will consider it as imaginary axis. That is, in the S domain, S is equals to sigma plus j omega. I mean sigma plus or minus j omega. Sigma is this one. Okay, j omega is imaginary axis. This is a real axis and this one is imaginary axis. So real axis here we have actually 0, minus 1, minus 2, and here 1, 0 like this. This is the real axis and this one is the imaginary axis. That is the S domain representation. It consists of a real and imaginary axes. Okay, now let us observe. Based on the roots, we are going to locate the poles and zeros on this S domain and then evaluate V naught of t from this pole zero plot. Is it clear, guys? Hello? Are you in a position to understand here? So number of zeros, s is equals to, that means s is equals to 0. So number of zeros means only 1. S is equals to 0 and only 1 0 is there. The number of poles, how many poles are there in the denominator? Ikkada oka pole, oka s, ikkada 2 s's. That means roots for this quadratic equation, 2 roots are there. So total 2 plus 1 and 3 poles are there. So what are the locations of the poles? Poles are located at s is equals to minus 2. S is equals to, first you have to identify the roots of this quadratic equation. After getting the roots, we have S is equals to minus 1 plus J1, minus 1 minus J1. These are the roots of the quadratic equation and these are the locations of the poles located on S domain. Guys, is it clear or not? Please tell me, Nana. Because first year guys, on first day, if I am explaining these concepts, beyond your what's it called, knowledge and understanding level, it's somewhat difficult to remember. That's the reason I'm asking once again. Is it clear up to this particular step? Hello? Tell me, Nana, please. Are you following or not?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, if you have any one of you doubt, please you can feel free and raise it out, ma'am. I'm not getting properly in that way. If you're keeping quiet and not raising a doubt, a teacher is not responsible for your understanding at the time. Okay? Sharon, are you following, ma?
Yes, ma'am.
Okay. Okay, is it okay? It's a time up. Okay, next class will continue, Nana. Okay, just wait a minute. I would like to take the attendance. Oh, 101 members present. Download list. Okay, we'll meet in the next class as a continuation of that yes domain, pole zero plot and evaluating of V of t. Is it clear, guys? Okay, bye. Because the next class will
Bye,
start.
ma'am.
That. Okay, Nana, bye now. I'm leaving now. Stop recording.